All right. So difference of two squares. So when you factor the difference of two squares, there's a couple of things I want to talk about. When we factor a quadratic, typically it looks like this. AX squared, this is the standard form, right? Plus BX, thank you. AX squared plus BX plus C. That's what we've been used to seeing, right? A quadratic trinomial. That's what we've learned to factor. How does the difference of squares, because this is also a quadratic, this is also a quadratic right here, but this is a quadratic binomial. This is a quadratic binomial. How is this different than the other one? It has two terms. Yeah. What do both terms look like, you think? What is a squared? What's another thing that I can say about a squared? Like if a was 3, what is the number 3 squared? What does that equal? 9. What do we know about the number 9? What do we call 9? Or if b was 4, if b is 4, 4 squared is what? What do we know about the number 9 and the number 16 and 25 and 36 and 49 and 64? Yeah, they're all multiplied by the same number. What are those called? Do you guys remember? They're called perfect squares. Perfect squares. Do you guys not remember learning perfect squares ever? Okay. So that's good. I printed out the sheet for all your perfect squares. So here we go. This is going to go in your journal, but this will help you get through today. 1, 2, 3. I'm just going to throw that there. If you have extras, just leave them on the back, okay? I'm just giving you a stack so you can keep going. There's some. There's some. Just for you. Okay. Okay. All right, perfect squares, perfect squares, perfect squares. So put them in your journal. If you need some more, holler at me. So these are called perfect squares. So when we factor the difference of two squares, it means that you have two perfect squares. Well, how do you unsquare something? We've done that before. Yeah, if I want to unsquare something, I find the square root of it. So you notice that when you want to factor the difference of two squares, you're going to take the square root of the first term, which is a perfect square, and you're going to take the square root of the second term times the square. So the square root of the first term plus the square root of the second term times the square root of the second term minus the square root of the third term. Here's really what it looks like. If you just take the square, I don't like the way that looks. I think I should have just put the square roots at the beginning. If you just take the square root of each of the terms, you're going to join one of them with a plus and one of your factors with a minus. You're going to join one factor with a plus and one factor with a minus. And here's why. So a couple of things you want to notice. They only have two terms. Both of the factors are perfect squares. So you take the square root of the first term and the square root of the last term. These square roots are joined as binomials with a plus sign and a minus sign. And that's it. These are probably the easiest things to factor. So we're just going to kind of jump into some practice. So is x squared a perfect square? Yeah, it is. So I'm going to take the square root of that. What is the square root of x squared? X. Is 9 on your perfect square list? It is. What is the square root of 9? 3. So the words over there said that you're going to take both of your square roots, right? And you're going to write them as binomials. The first one join with a plus, and the second one join with a minus. I want to FOIL that and show that that works because that looks weird to me. So let's see. X times x is x squared. x times negative 3 is negative 3x. 3 times x is a positive 3x. And 3 times negative 3 is negative 9. What happens to these two terms in the middle? Yeah, they cancel each other out. Absolutely. So I have a perfect square minus another perfect square. Remember, the word minus means difference. So that's why this is called the difference of two squares. Okay? All right, so let's do it again. First term, I need to know the square root of 4x squared. The square root of 4x squared. Well, what's the square root of 4? 2. And what's the square root of x squared? Okay. I also need to know the square root of 25. 5. So what's this going to look like, Jaden? How do I write my two perfect squares? And absolutely, 2x plus 5 times the quantity 2x minus 5. So that's how I write the square root of my perfect squares. That's exactly what we're going to do every single time. What is the number one rule about factoring, though? I forgot it. What do we always want to check for first? Yeah. So don't forget, you first want to look for a GCF. Okay, that's the number one rule. You want to watch for that because we might sneak one of those in here, okay? So let's look at number 3. So look at your perfect squares list. I need to find the square root of 16x squared. Square root of 16x squared, Seamus. Look at your chart. What's the square root of 16? 4. And what's the square root of x squared? X. Good job. Square root of 225, Amalia. Say again. 15. Absolutely. Carla, what's this going to look like? What are my two binomials? Yes, ma'am. Absolutely. What do we think about this? Pretty simplified. Oh, can that be simplified? Huh? No, yeah. No common terms there. Good thinking, though. Oh, what about this one? It even gave you a note. It says, remember, look for a GCF. Gianna, I just pulled your stick. Do you see a GCF in this? What is it? GCF. What number divides both 20 and 405? 5. Yes, ma'am. I have to. Sorry, 5. So we're going to pull out a GCF of 5. And when we do that, let's see, 20 divided by 5 is 4. And that's on our perfect squared list, thank goodness. And 405 divided by 5 is 81. Is that on our perfect square list? Excellent. Okay. So I'm going to write the 5 out front so I don't forget about it. So I don't want to forget about it. And I need to figure out what the square root of 4x squared is. So square root of 4x squared, Jaden. 2x. Square root of 81, Bailey. 9. So what are my two binomials, Violet? Absolutely. What are we thinking? Good. Okay. Greatest common factor here. What do you think, Brian? Greatest common factor. Do you see one? Do you know what it is? 5. Yeah. 5. If you take out a GCF, remember you should end up with two perfect squares. If you don't, that means there's another one in there. There's a bigger one. Okay. That's just something to look for. What is 180 divided by 5? 180 divided by 5 is 36. So I have 36 x squared. Zan, I'm coming to you in a hot second. Minus 245 divided by 5, Zan.
49.
Perfect. All right, Tayana, square root of 36x squared and 49. X and square root of 49 is? Perfect. Uriah, what are my two binomials? 6x plus what? Okay. Good job. Remember that we put that 5 that we pulled out originally in front, right? That's still one of our factors. That is still one of our factors. You can't just discount that, right? It's still part of the problem. Okay. Next one. Brayden, what do you see as a greatest common factor? There's something bigger than 3. And I don't think 847 is divisible by 3. What do you think, Ashton? Nope, it's not divisible by 6. What do you got, Jaden? 7. Yeah. These are both divisible by 7. So I'm going to take my 7 out front. Don't forget that I want to put two binomials there. 63 divided by 7 is 9x squared. And 847 divided by 7 is 121. Okay. Square root of 9x squared, square root of 121. Luke, square root of 9x squared. Just 3x. And then square root of 121? 11. Perfect. What are my two binomials going to be, Cameron? Absolutely. Don't forget you need to have your 7 out front, okay? What are y'all thinking? Good? Okay. So what about this one? Is there a GCF? Huh? 5. 12 is not divisible by 5, but you're close. There is a GCF. It's just not 5. 3. Yeah. 3. So when I take a 3 out, I have 4x squared plus 25. Can I factor that? Yeah? What lesson is this today? What is this called? Read up top. What is our lesson called? The difference of two squares. God bless you. And we use the acronym DOTS, D-O-T-S. So is this sign a difference sign? No, that is not a difference. That is a sum, right? Plus means sum. So I have a note here that says the sum of squares. These are not factorable. These are not factorable. So if you were to factor this, this is as factored as you can get it. You can only take out a GCF. There are no two numbers that you can multiply together to get let's just try the AC method. Product, A times C. 4 times 25 is 100. The B term, the X term is 0. Are there two numbers that you can multiply together to get 100 that when you add them, you get 0? No, there aren't. You need a positive and a negative, right? That's why that doesn't work. So you cannot factor the sum of squares. You can only factor the difference of squares. Okay? All right. That's our video.